Lesson number 7. This looks at another way of solving quadratic inequalities algebraically using what we call sign analysis, which I think you may find a little bit more kind of a better process and better organizational tool than the case analysis that we're looking at yesterday. So if we look at the first part, if we look at what we call test intervals. So we have the graph of the quadratic equation, y equals x squared plus 2x minus 8. The zeros of the function are -4 and 2, and they can be used to divide this graph into, or to divide the x-axis into 3 intervals. We have the numbers leading up to -4, the numbers leading between -4 and +2, and the numbers that are greater than +2. So on the interval that leads up to -4, this part of the graph, is it positive or negative? It would be positive. It's above the x-axis. The interval between -4 and +2 is negative, and the interval that is greater than +2 is positive. So the sign, or in this interval, the sign of the quadratic, positive, negative, and positive. So the parts of the graph that are positive would be the parts of the inequality that is greater than 0. So that would happen when x is less than -4 or when x is greater than +2. And then the solution of the inequality that is less than 0 would be the part of the interval that's negative, which is that part that is between -4 and +2. But sometimes the idea or having to graph the function is not always what we want to do. So we could use what we call sign analysis instead of case analysis to be able to do this algebraically. So if we consider the inequality x squared minus 9x plus 14. To solve this inequality, we think of it as a quadratic first, and we look at solving the quadratic. So to solve quadratics, we start off by factoring. So how can I factor this quadratic?
X minus 7 and x minus 2.
Okay. So I had x minus 7 times x minus 2 is equal to 0. So if I look at it as an inequality, instead of letting it equal 0, I'm now going to have it as less than 0. And then I'm going to put my equation over on the other side. So what are my 2 possible zeros? What are my 2 possible x solutions if I look at this equation? 7 and 2. Now, when we were doing the case analysis yesterday, what we had to consider is if this is less than 0, meaning if it's negative, that means that this factor could be positive and this could be negative, or this factor could be negative and the other one could be positive. We had to consider both situations. Well, what we're going to look at this time is we're going to actually look at test intervals. So again, if I picture what this quadratic would look like, when I graphed it, on the number line, that quadratic is going to intersect the x-axis at 2 and at 7. Those become my anchor points in my test intervals. So what I have is I have all the numbers that are less than 2, all the numbers that are bigger than 7, and then all the numbers that are in between. So give me a number that's less than 2. 1. Okay? So if I put 1 into this equation, I get 1 squared, which is 1, minus 9, which is -8, plus 14, which is sorry, 6. Yes.
Okay.
So 6 is positive. So the sign of that inequality would be positive. That part of the graph would be above the x-axis. So now if I think of a number between 2 and 7, such as 5, okay, what's 5 squared?
25.
And 9 times 5? So what's 25 minus 45?
-20.
Okay, and then if I take negative 20 and I add it to 14, am I going to get a positive number or a negative number? Negative 6. So this interval becomes negative. And then if I do the same thing, I pick a number bigger than 7, such as, give me a number bigger than 7. 10. So I have 10 squared minus 9 times 10 plus 14. So what's 10 squared? 100. What's 100 minus 90? 10. And 10 plus 14? So I get a positive answer. So we had chosen 1. So 1 squared minus 9 times 1 plus 14 was 6. And then you chose 5. So 5 squared. So then if I was looking at the solution to the inequality that is less than 0, I would be looking for the parts of the graph that are negative. So then the solution would be the values between 2 and 7. And I can use this interval chart again to help me find the solutions for different inequalities. Such as if the inequality is greater than 0, then those are my positive answers. So when x is less than 2, or when x is greater than 7. And then if I make them equal to, so when it's less than or equal to 0, that means that x could actually equal those interval points. It could actually equal 2, it could equal 7. And the same thing when it is greater than. It means that x could be less than or equal to 2, or it could be greater than or equal to 7. So the values that we used for this, we call them our test points. So if we do one more example, solve the inequality 8x minus x squared is less than or equal to 0 using test intervals. So we want to start off by factoring. There's only 2 terms, so when we factor with 2 terms, our flow chart that we looked at, can't remember which chapter it was now, a couple of chapters ago, said the very first thing that you always look at is can you factor out a greatest common factor? So is there a common factor between these 2 terms?
X.
Okay, so if I take out an x, what am I left with?
8 minus x.
Then I look at the 2 factors, or the factors that I have left, and I just double check, can I factor this further? So can I factor an 8 minus x further? No. So what are my 2 possible intervals? So think of this, if this was an equal to 0, what could x equal?
0 or 8.
0 and 8. So my zeros are 0 and 8. So then my intervals means I'm going to have all of the numbers that lead up to 0. So that's all the values less than 0. Then I have all the values that are in between 0 and 8. And then I have all the values that are greater than 0. Or sorry, not greater than 0, greater than 8. And then what I'm going to look at is I'm going to look at what is the sign of the inequality in each of these cases. So pick a number that is less than 0.
-1.
Okay? So if I put that into this this equation, I'm going to get 8 times negative 1 minus negative 1 squared. So what is 8 times negative 1?
Negative 8.
Negative 8. And negative 1 squared? 1. So I'm going to get negative 8 minus 1, which is, so then the sign here is negative. So now pick a test point between 0 and 8.
6.
Okay? So 8 times 6 is
48.
48.
You wanted 6.
And 6 squared.
36.
And 38 minus 36.
12.
Which is what type of an answer? Positive.
Okay, so I guess you remember.
And then pick a number greater than 8.
10.
There we go.
Good choice.
So I get 8 times 10 minus 10 squared. So 8 times 10
80.
and 10 squared.
100.
So it's 80 minus 100.
Negative 20.
So I get
Crushed it.
negative. So now if I'm looking at solving the inequality that is less than or equal to 0, I'm looking for the parts of the graph that are going to be negative. There are my 2 intervals. Because it can be equal to, I would write it as x can be less than or equal to 0, or x can be greater than or equal to 8. So I'm going to give you 2 questions to practice on, 1A and 2A. And then I'm going to show you an organizational tool that will help. So using sign analysis can be possibly a little bit more useful than using the case analysis, but there's still a lot of work that goes in there because I have to go through and I have to pick these test points and I have to plug them in. So again, is there a way that we can streamline this process, a way that we could make it easier? So if we look at the beginning of this lesson, Colin's looking at the inequality x squared plus 2x minus 8 and solves it using test intervals. So he has an older brother who shows him a different way that this can be solved. And this method would work no matter if I had a quadratic, if I had a cubic, if I had a quartic, no matter what the degree of my inequality was, I could use this type of system. So what his brother states is, you know what, let's factor this out. So we factor out the quadratic, we get x plus 4 and x minus 2. From this factored expression, I identify what my zeros are, my x-intercepts, negative 4 and 2. So before, what we did with those zeros is we made our intervals. We had all the numbers leading up to negative 4, the numbers in between negative 4 and 2, and then all the numbers bigger than 2. So he kind of does the same thing. But instead of putting it as test intervals, he just has it as x values. These are all the x values that are less than negative 4. Negative 4 itself, the numbers in between, 2, and the numbers bigger than. And then what he does is he separates out the factors. Because in my inequalities, 0 is always on the right-hand side, or it's always less than 0, greater than 0. Like it's always zeros on one side and the quadratics on the other side. So if I separate my factors out and I use this idea of 0, when x is equal to negative 4, this factor here is 0. If the numbers are greater than negative 4, such as 1 or 2 or 0, this factor always remains positive. So I can fill that part of the chart in as being positive values. If it's a number less than negative 4, such as negative 5 or negative 10, this factor in itself becomes negative. And then I can do the same thing with my other factor. And what I end up with is I end up with what the signs are for each individual factor. Then, because we've got a product of factor in our factored quadratic, I'm going to find out what the product of my factors is, and I'm going to record that product. So if I take two negatives and multiply them together, I get a positive. Anything that is a 0 will remain as 0. Positive and a negative gives me my negative, and then my two positives gives me a positive. So this way here, my numbers in my factors are usually smaller. They're usually easier to work with. Less time consuming than having to do what we did on the previous page, which was picking values and substituting the values in and having to solve for them. This way, I can do this by mental math. I can look at this and I should be able to very easily determine if my number is bigger than -4, my answers are always positive. Not to mention, if I put this in numerical order, it will always form a pattern. The 0, everything to the right is positive, everything to the left becomes negative. And then when I look at my products, the inequality is greater than 0, so I'm looking for positive products, and there's my factors, or there's my intervals. All the numbers that are less than -4, all the numbers that are greater than +2. So the method looks complex at first, but once you start using it and you get it set up, it's actually a better organizational tool than trying to use the case analysis or even trying to use the test intervals. Okay? So if we looked at this chart and we were to declare what the solution was for the inequality that is less than 0 is going to be the negative part of the chart, and the negative part of the chart occurs between -4 and +2. So then my solution would be the values between -4 and +2. Now, where this method can become extremely useful is when your quadratics start to become more complex. So if we look at the quadratic, -6x² minus 39x minus 18. If we wanted to factor this, our first step, can I divide those three terms by a common factor? Okay, and because this is a -x², let's divide it by a -3. So if I divide it by a -3, what do I get? 2x² okay, and now I want to factor this. Because 2x² is a prime number, the only combination I can get for that is 2x and x. Now 6 is a little bit more because 6 I could have 6 times 1, and I could have 3 times 2. So I would need to kind of go through, maybe do some guessing and some checking to figure out which one should I use. Should I use 3 and 2 or should I use 6 and 1? Given that the middle term has to equal 13. 6 and 1. Why did you choose 6 and 1, Rachel?
Well, I looked at it and I saw I could go 12. 2 times 6 is 12 plus 1 is 13.
There we go. So 2 times 6 gives me my 12, and then 1 will end up with my 13. Okay? So there's my expression is factored. So then what would my zeros be? So if this equation equaled 0, what values of x would make that equal to 0? -1/2 and -6. So now when I go to put this in as my chart, along the top I have my x values. We have 5 columns because we have 2 zeros. So my columns always go the same way. I have all the values that are less than the first 0, then what the first 0 is, the values in between, the next zero, and the values bigger. Putting the zeros in the order that you put them in is important. You want to put them in numerically. So which zero would go here? -6. Because my number line would increase from left to right. Then I put in what my factors are. So because I have, in a sense, I do have 3 factors. That -3 is a factor. It has to be included in that chart. And then I need the 2x plus 1 and the x plus 6. So that that -3 does become important in my inequality. It does become important in my sign chart. Now the sign of -3 is always going to be negative. Doesn't matter what the x value is. It's always going to be negative. So now if I look at my 2x plus 1, it equals 0 when x is equal to -1/2. Anything smaller than -1/2, such as like a -2, 2 times -2 is -4, plus 1 is -3. Everything's going to be negative. Anything bigger than -1/2, like 0, is going to be positive. And then I do the same thing for my x plus 6. The 0 happens when x is equal to -6. Anything smaller than -6 would give me a negative. Anything bigger than -6 would give me a positive. So now that I have my signs filled in, I'm going to find the product of each column. So if I multiply 3 negatives together, what do I get? So a negative times a negative times a negative would give me a negative answer. My zeros, so wherever I see a 0, the product's going to be 0. It doesn't matter how many positives or negatives I multiply. That 0 cancels it all. A negative, and a positive. And then a negative, positive, positive. So my inequality is less than or equal to 0. So that means I'm looking for what kind of answers? Negative answers. And it can also equal 0. So I'm looking for those zeros as well. Which means in this case, it's all the values that are less than or equal to -6. So x can be less than or equal to -6. Or x can be greater than or equal to -1/2. Okay. It seems complex because it's a lot of work to set it up, but when you start plugging the numbers in, it's far easier to solve these individual factors than it would be to try to pick, because I'd still have to go through the same steps. I'd still need to identify what my intervals were, and then I'd have to pick test points. And I'd have to plug those test points into this equation, which ends up being more cumbersome. The numbers are larger. There's more room for error. So your questions to practice using this sign analysis with the sign chart, if you can, would be questions 3B, 4A, 6, 8, and 10.